Okay, so de Broglie, important person, he argued that if light can be a wave and be a particle, then matter, which is an electron, anything like a mass, can behave like a wave as well. Remember, light is a photon. Okay, so the first evidence that we have, an experiment that you should know, is that we found out that matter can have wave properties from the Germer and Davison electron diffraction experiment. Okay, this is an important experiment that told us that matter can have wave properties. Told us matter can have wave properties. So, light can have pause. Okay, so look at the de Broglie equation. I'm going to write this out a little bit bigger so that we can see. Planck's constant over mass and frequency. Planck's constant and wavelength. Okay, so looking at that equation, the bigger the mass, the smaller the wavelength. So someone who is a human and weighs around 100 to 200 pounds is going to have a smaller wavelength than an electron, which is teeny tiny with a small mass. So a human has a wavelength around 10 to negative 36 meters. Okay, that is a human's wavelength. Okay, this is going to be key. Let me pull up something real quick. An electron, which has a bigger mass, a smaller mass compared to humans, is going to have a wavelength of times 10 to the negative 9 meters, also known as nanometers. Yep. A proton, which is a little bit bigger than an electron, which meaning that it'll have a smaller wavelength than an electron, will have a wavelength of 10 to the negative 12 meters. These are picometers, also known as picometers. Okay, so as you get bigger, your mass is greater, giving you a small wavelength. And then the smallest, which is an electron, will have the biggest wavelength. And then proton, 10 to the negative 12. Please remember this for your test tomorrow.